Today I'm going to talk to you about the language of polynomials. So what is a polynomial? You've already come across some polynomials earlier on. You should be familiar with function notation here, P standing for polynomial, X a function in terms of X. I'm going to just write a polynomial that's a quadratic. This is something that you've met before. And you can see here that a quadratic has a leading term of an x squared. And of course, a, b, and c, as we're familiar with, are just the coefficients. And what happens with a polynomial, this is a polynomial of degree 2, is that the powers, we start with the highest power and they reduce, that's technically x to the power 1, and that's technically x to the power 0, because we should know that x to the power 0 is just 1, so therefore that's just 1 times 1, which leaves it as the constant term. So, of course, you can meet other polynomials such as cubics. A cubic has a leading term which has a power of 3 to the degree of 3. So a general cubic might look like this, for example. Again, we're familiar with the fact that it may not have every single term, but if it has a leading term, i.e. the highest degree of power, that's what we call the leading term of a cube, then, or degree 3, that means it is a cubic. And we can, of course, keep going up in degrees. So a quartic would have a term, the leading term would have to the power 4. So ax to the power 4 plus bx to the power 3 plus cx squared plus dx plus e, for example. And we can keep going up. And this is what we call a polynomial. In any polynomial, we have a constant term usually, and the leading term, and then all the other terms. So what I'm going to do is talk about this here, and when we talk about a solution to a polynomial, we're talking about a value of x which works for this equation, okay? So we might be talking about p of 1 equals 3. Well, that means when x is 1, the whole equation equals 3. And so we're going to be looking at some of these. So I'm actually going to do some calculations with some polynomials. I'll just clear some space. All right, so this polynomial, I'm going to find p of 1. I'm going to find the value, what does this equal when x is 1? So I'm going to sub in 1 into my polynomial. Now, I noticed this leading term here because it's got the highest power. This is the leading term, so therefore it's a quartic, or a polynomial of degree 4. I'm going to work this out, and I always put what I'm substituting in brackets, and then I can worry about any negative terms and make sure I don't make any errors. So 1 to the power 4 is 1, minus 1 to the power 3 is 1, minus multiplied by 3 is minus 3, minus the 2 gives me minus 4. Now I'm going to work out p of negative 1. Let's find out what's the value of this when x is negative 1. So again, I'm subbing it in using my brackets so I don't make any mistakes. I can work each thing out individually. Now, when I put this to a power 4, this becomes positive. So that becomes 1. This to the power 3 stays in negative 1. And then I'm actually multiplying it by a negative 3, so it becomes plus 3. And then I've got minus 2. So altogether, my answer is 2. Okay. All right. As you can see, I've written a new polynomial up here, and I've got some information. And what I want to do is use this information to find out what's the value of c. So let's look at the polynomial. We've got a leading term here because it's to the degree 4, constant term 6. This has the coefficient of x, and the coefficient of x cubed is minus 1. Over here, we've been told if p of 1 equals 21, and obviously we can use that information. This means that when x is 1, the value of this polynomial is 21. So I'm going to sub this in. So we get 21 equals. So I'm going to sub in when x is 1 now. So as always, I just do the straight substitution first, and then I can tidy it up later. So 21 equals 1 to the power 4 is 1, so that's just 2, minus 1, that's just plus 2c, plus the 6. Collect together any like terms. 21 equals 2 take 1 is 1, plus the 6 is 7, 7 plus the 2c. Okay, I can now take away 7, 14 equals 2c, so therefore c equals 14 divided by 2, which is 7. My polynomial then becomes 2x to the power 4 minus x cubed plus 14x plus 6. I'm going to use the same polynomial again with some, no I'm not, I'm going to use different information. Alright, this is a bit trickier. This right down at the bottom, this is a really hard example. I've got a polynomial here where I can see it's a cubic. some leading terms. And I've been told that it can also be written in this form here, which has constants b, c, and r. And the question is, can you find b, c, and r? So the first thing I'm going to do is I'm going to expand this because it tells me that this can be written as this. So let's expand this, and hopefully I'll be able to then find any coefficients of each of these and solve those individually. So I'm going to expand this. So when we expand something with a cubic, don't forget we'll have to include this plus r, but we'll do that later on because we're just going to do all the brackets first. Each term inside this bracket needs to be multiplied by each term inside that bracket. So this one needs to be multiplied by that, and that. So I'm going to just do that as an expansion just underneath here. Actually might need some more room. So I get x times x squared is x cubed plus b times bx times x is bx squared plus cx. Now moving on to this term, so I get negative 2x squared. Negative 2 times bx is negative 2bx, and then negative 2c. And then don't forget I've got to write the plus r. I'm going to collect together some like terms. We do have some like terms. This is an x squared. This is also an x squared. But I have different quantities. So what I'm actually going to do is group them together and factorise them to pull the common factor between these two terms out. So I'll start with x cubed. So if I look at just these two terms here, x squared is the common factor, and that's multiplied by b, take 2. And I'm going to do the same with these two terms here. They're both like terms with x, this one and this one. This is positive, this is negative. And I'm going to again pull out the common factor x, and I can see that it's multiplied by c here and minus 2b here. All right, now these two terms don't have any x's there at all, so they are constant terms. So I'll just leave them as they are for a moment. And then what I'm going to do now is I'm now going to look at, well, what's the coefficient of the x cubed? Well, that matches. What's the coefficient of the x squared? Well, 3. 3 has to equal b minus 2 because that is what the coefficient of the x squared is. And remember, these are the same. So let's just solve that individually. B minus 2 has to equal 3. So that means b has to equal 5. I can do the same with this term. The coefficient of the x here is 2. Coefficient of x here is c minus 2b. So c minus 2b has to equal 2. I know that b is 5, so I can sub that in and solve for c. c minus 10 equals 2, so c equals 12. And finally, I can do the same with a constant. The constant here is 1. These two terms here involve the constant. So minus 2c plus r has to equal 1. c is 12, so minus 2 times 12 plus 1, so it's minus 24 plus r equals 1. So therefore, r is equal to 25. Hopefully, that gives you a bit of an idea about what we can do with polynomials.